Good morning, everyone. So I'll be discussing about Python across ArcGIS today. So I'll be taking you through various capabilities of Python within ArcGIS platform, some use cases and demonstration. So to begin with, I'll just give a brief overview of what Python is. You may be aware of Python programming language, but I'll be giving a brief. So Python is one of the most commonly used general purpose programming language. So it is very similar to the human syntax. That is why it is very popular and it is very easy to use. So if you are using ArcMap, you will be seeing a Python version there, but in ArcGIS Pro, in our latest desktop product, ArcGIS Python 3 version is there. So Python was introduced to the ArcGIS community with ArcGIS 9.0. In ArcPy, Python 2 series was used, but in ArcGIS Pro, the Python version higher than 3.5, 3.4 or equal is used. So in ArcGIS, if I am saying about the capabilities of Python in 3 words, I can say that it can be used for Web GIS administration, content management, and analysis and data science. So in ArcGIS, we have 2 important libraries specifically designed for this data science and analysis workflows. One of them is ArcGIS API for Python. It is a Python site package. So a site package means it will be composed of various modules within. So modules means it will be having a set of codes which are defined to perform a set of analysis operations or workflows. So ArcGIS API for Python is a Python site package of ArcGIS, which is having different modules within it. So it can be used for spatial analysis, mapping and visualization. It is a very powerful modern library and it is very easy to use, and it is very well integrated with the ArcGIS platform. And it is also powered by Web GIS, and it also has local capabilities along with the Web GIS capability. I'll be discussing this in detail in the coming slide. This is the another library which is called ArcPy. It is also a site package which is having different modules within it. So ArcPy is majorly desktop based. So whatever the geoprocessing tools that you have in ArcGIS Pro, you will be able to consume it in Python with the help of ArcPy package. So ArcPy also has different modules based on which the geoprocessing tools in ArcGIS Pro are written. So in ArcMap, it was there, and in ArcGIS Pro also it is there with some additional enhancements and capabilities. It is mostly used for geoprocessing and can also be used for some kinds of map automation. In Web GIS also, Web GIS means ArcGIS Enterprise or ArcGIS Online, which is the ArcGIS product which is having the Web GIS capability. It has an in-native notebook integrated with it, with the which is called notebook server. Using which you will be able to use ArcGIS API for Python. ArcPy can also be used there in the advanced version of notebook server. So this is ArcGIS API for Python general capabilities. So it can be used for administration workflows. Administration workflows means if you are using ArcGIS Enterprise or ArcGIS Online for your WebGIS task and all, the administrators can use this library to create items in the portal, to manage item, to create application, to add users. So if you want to monitor whatever the activities are happening in your enterprise portal or in your ArcGIS online platform, ArcGIS API for Python can be used for automating it. So it will send you alert if you are defining a workflow, like you have to, if you have to be notified when a particular user is adding or deleting an item, or if you want to manage the content of your enterprise site, this library can be made use of. And apart from that, it can also be used for imagery and analysis kind of workflows. In ArcGIS API for Python, it has a module called raster module, which is specifically designed for analyzing raster data. So that can also be used for handling large imageries and all. And content publishers can also make use of it for publishing your content. So if you want to create application directly from a feature layer after updating it with some real-time information and all. This library's various methods can be made use of. In short, it can be used for scripting and automating your WebGIS workflows. So this is the API overview. These are the various modules within this ArcGIS API for Python site package. The package is called ArcGIS API for Python, but in the notebook, when you are using it, it is named as ArcGIS. So you have to import a Python site package called ArcGIS within your notebook to leverage all these capabilities. So within this ArcGIS site package, these many modules are there. So this GIS module is specifically for connecting to your WebGIS. So using this GIS module, you will be able to establish a connection within your between your enterprise or HUL within the notebook interface. And there are a raster module, feature module, and learn module is designed for machine learning and deep learning workflows. So if you want to train a model, if you want to like predict on some images using a deep learning model, this learn module can be used. And apart from that, various other sub modules are also there for geo enrichment, mapping, application creation, like that. So these are some of the important modules within this ArcGIS package. And coming to the Jupyter Notebook integration with ArcGIS platform. So you may be aware about a Jupyter Notebook. It's a Python IDE. So the Jupyter Notebook is integrated within ArcGIS Pro as well as in ArcGIS Enterprise and ArcGIS Online. So in ArcGIS Enterprise and ArcGIS Online, ArcGIS Enterprise, it is a additional server role which is called Notebook Server. Where you will be able to see a Jupyter interface just like the native Jupyter Notebook platform. So the entire ArcGIS API for Python is designed to make most of the Jupyter's functionality. You can use the notebook just like you are coding in any Python IDEs. There will be various options. When it comes to notebook server, you will be having some enhanced functionality for scheduling your notebook, for creating tasks. So many additional configurations can be like made use of from this Jupyter notebook integrated within ArcGIS platform. That is about the interface, and it's very similar to the traditional Jupyter notebook, but some additional enhancements are there. In ArcGIS, as I said, you can use the notebook in 3 or 4 products: ArcGIS Enterprise, ArcGIS Pro, and ArcGIS Online. ArcGIS Pro, you will be able to use ArcPy and all. And in Enterprise and HUL, ArcGIS API for Python can be made use of for automating all your WebGIS tasks. ArcGIS Notebook sits at the intersection of ArcGIS and data science. So, in ArcGIS Notebooks, you won't be able to use our libraries, but you will also be able to use various other open source libraries. So, in a Python world, like there are various open source libraries, right, for analysis, mapping, visualization, and all. Various other open source libraries are also can also be imported in your workflows. There is no limit. If you want to install some additional libraries, that can also be possible. There is like a enhanced like capability of the notebook server, which will allow you to install any libraries by creating a clone of your Python environment. So in ArcGIS Pro, there will be default Python environment. You won't be able to modify or alter anything in that settings. But if you want to install some additional libraries that is not there in the default installments, you can create a clone of your Python environment in ArcGIS, and then there you will be able to install any other libraries that you want. So how is ArcGIS notebooks different than traditional Jupyter notebook? So the one of the major differences that it is built within ArcGIS platform. It is not sitting outside ArcGIS. It is tightly integrated within our ArcGIS product. And it is having an integrated user interface where you will be able to automatically insert Python snippets, and there is a gallery of sample notebook which you can use for starting your coding workflows. And the notebooks can be shared as items between various users of your ArcGIS enterprise or ArcGIS online organization. So these are some of the additional functionalities or additional capabilities that makes ArcGIS notebooks different from the Jupyter notebook. So why do we talk about Python and notebooks together? So we talk about Python and notebooks together because if we want to automate any complex task, or like for example, if you want to automate the processing of time series raster images, or if you have a feature class or shapefile which is having lakhs of records and all, these workflows will be making the entire process simpler by writing a code. And this is how the Python in ArcGIS looks like. So in ArcGIS Pro, you'll be having a Python Minto integrated within it, where you can use a top of libraries, and ArcGIS API for Python can be used in ArcGIS Enterprise or ArcGIS Online. So it is an integrated experience within Web GIS. Apart from this common automating task and all, machine learning and deep learning tasks can also be uh, replicated within your ArcGIS notebook. So as I mentioned earlier, there is a library called ArcGIS Learn, which is having various methods, which is having various algorithms integrated with it to train object detection or pixel classification models and all. So using that libraries, you will be able to fetch the integrated algorithms for performing various deep learning tasks. You can ingest your data, you can do the training of your model, you can take the model output in deep learning package format, which can be used for inferencing or predicting in your input images. So the entire machine learning and deep learning workflows, which you will be able to get through various geoprocessing tools in ArcGIS Pro, can also be consumed as Python with the help of ArcGIS Learned library within the integrated Jupyter notebook. So this is the deep learning or object detection workflow in ArcGIS. You may be aware. So first we'll be starting with labeling the training data, and we'll be preparing the data, and we'll be training the model, and we'll be doing the inference. So in this training part, you can use a notebook for training your model. Just like you are using the geoprocessing tools, the similar workflow can be replicated using this ArcGIS API for Python library, and you will be able to get a trained deep learning model package. So now you will be wondering, if you have geoprocessing tools in ArcGIS Pro for training object detection model, then what is the use of ArcGIS API for Python for training the model, right? But sometimes the data that you are getting for training your deep learning model will be public data sets or non-georeferenced images, right? So in that scenarios, you have to use this ArcGIS API for Python for training your model with some public data set that you're getting, or with some non-georeferenced images that you're having. Apart from that, you will also be having some of the labeled data sets that you'll be getting from some open sites and all, right, for training your model. In that case, that data cannot be supported within ArcGIS Pro for training your model. But in those scenarios, that data can be directly used within ArcGIS Notebook to train your deep learning model. And the output of this training within ArcGIS notebook is exactly similar to the output that you are getting from the geoprocessing tools in ArcGIS Pro for training your deep learning model. Yeah. So that is about some of the like capabilities or Python overview within ArcGIS platform. Now I'll be proceeding to the demonstration. Yeah, so I'll just start with basics. So you may be aware, but if you are not familiar with this interface, I'll be just explaining it. So in ArcGIS Pro, if you want to use a notebook, there are two options. You can go to the analysis tab, and under this Python drop down, you will be getting two options called Python notebook and Python window. So if you click on Python notebook, an interface similar to the Jupyter notebook will be opening. If you are opening Python window, a very small box will appear at the bottom of the ArcGIS Pro. So here also you can write your code, and here also you can write your code for analysis or various kinds of workflows that you are interested in. So I'll be just showing some of the basics that we can do. This is the ArcPy library that I was mentioning about. So this is the foundational Python side package within ArcGIS Pro, which can be used for like making all the geoprocessing task within ArcGIS notebook. So you can import this library just like the import option that you will be doing in the traditional Jupyter notebook environment, and you can set the current workspace using the arcpy.environment.workspace parameter. If you are setting workspace, whatever the analysis that you are doing, or that will be the output will be saved there, and you will be able to fetch the data that is there in your workspace. So here I have set my workspace to one of the folder, and if I want to see what are the image like raster objects or raster images in my workspace, I can use this list raster function in my ArcPy library, and if I am running this, I'll be able to get what are the rasters available in my workspace. And so here I am just running a simple code for creating composite band using these three layers. So here I have added the composite band method from the ArcPy library, and I have given my rasters, and I'm just giving one output name, and I'm running it. So the advantage is that so for two or three images, you won't be it is not necessary to use notebook for creating composite band. But if you have large number of images, then the usage of notebook will be very helpful in automating the entire workflow. So I have run this command, and it has successfully run, and this is my output. And I'm just going to my GDB, and this is the composite band I have just created, and I can add it to my map. So the output that we are getting is very similar to the GP tool. It's not very similar, it's the exact output that we are getting from the GP tool. There is no difference in that. And now you might be wondering, like, if you are not new to Python programming, but you want to make use of this notebook by writing code for automating some of your workflows. So if you are struggling to get code for this, what you can do is that if you have any doubt in any GP tool code that you have in ArcGIS Pro, you can run a sample a tool with some test images from the geoprocessing tool window. And once you run that tool, you can go to the history tab, and in history tab you will be able to see the successfully completed a geoprocessing task, right? If you right click on this, there is an option called copy Python command, which can be used for copying the corresponding Python code associated with it. So I can copy the Python command and I can paste it here. So I'll be able to get the corresponding Python code associated with it composite band geoprocessing tool. So in a similar manner, for every geoprocessing tool, you can use this same method and you will be able to identify the code behind it. And after evaluation, this code can be modified according to your workload. Yeah, so this is one sample use case where you are setting one workspace and you are getting the rasters from the workspace and creating a composite map. This is just a simple workflow. And now I'll be showing one creation of mosaic dataset with a set of raster images I have. So most of the time, if you are looking into temporal data, in case of raster images, it will be very big. And if you are downloading it from some sites and all, we won't be able to get the raster image for our exact area of interest, right? So here I had one raster image, which is showing the aerosol optical thickness as a raster. I have downloaded it from the NASA Earth observation page. But here you can see that I won't be able to define an extent there. I'm getting an image, raster image for the entire world extent. But I want to do an analysis and I want to create a mosaic data set by clipping it into my area of interest, which is my Indian boundary. Indian boundary is my area of interest here. So here I have downloaded data from 2016 to 2022. Okay, this is a 5 or 4 years data only. But if I am downloading like data from like 1990 to 2023, if I am manually doing the clipping and if I am manually doing adding the raster to mosaic dataset, then it is not AC. Then it's not an AC process. It will be a very time consuming process, right? So instead of that, what we can do is that here I'll be showing a workflow where I have added my folder of images to this notebook. Then I am automating the workflow of clipping the image to my area of interest, and I am creating a mosaic dataset and I'm adding that rasters to my mosaic dataset. Okay. So here I have imported my necessary library and I have added the folder path here, and these many raster images are there in my folder. And this is my code for automating the clipping of image to my area of interest. So this code will be clipping each raster to my area of interest, and I have created a mosaic dataset named mosaic aerosol, and using this a function adding rasters to mosaic dataset, I am adding every clipped rasters to my mosaic dataset. Okay, so you may be wondering like you can replicate the same workflow by creating a model builder, right? Okay, you'll be able to do that, but here what was my challenge is that when I'm downloading the image, the corresponding date associated with the image was within the name of that particular image. Okay. So I wanted to extract this particular date from this image and I wanted to add it to the date field of mosaic dataset. So using this Python, I could just write a simple command for extracting the date from the name of the raster, and it got added to the date field of attribute table of my mosaic dataset. So I'll be showing the output. So this is the raw image and this is my mosaic dataset. And if I'm looking into the attribute table associated with it, you will be seeing that a date has been added here. So here this has been like made time aware. So using this time slider, I'll be able to see how the aerosol optical thickness has been changing over the year from 2016 to 2022. So this time slider will be added if you are making your data time aware. So basically you have to add one date column or time column which is having date type within your attribute table. So in order to add this date field, I had to write one command which will be extracting the date from the name of the raster, and it will be adding to this date field correspondingly. Okay. So this is one raster automation workflow. And next one, so till now I have talked about how we can handle rasters, right? What about then feature class? If you have to deal with feature class or shapefile having lakhs of records, then what is the way? It's similar workflow can be um, replicated using this ArcPy library. So in ArcPy, there are modules for dealing with raster images, and there are modules for dealing with feature classes as well. So here, this is one use case where I have some feature class which is having like around 1 lakh records, and it is the various protest happened in India over some years, and it is having different types. So within this event type itself, you will be able to see various types, right? Like protest, riots, and all. So basically, I wanted to calculate hotspot for each event type. Okay. So if I am doing it manually, I have to filter the data for different event times, and I have to do this hotspot calculation and all, right? So here there are like 1 lakh records. So here using this ArcPy, I am listing the feature class within my current workspace. So events is one of my feature class within my current GDB, and I'm just looking the schema of my feature class, which is having these many fields and all, and I'm adding some additional information from CSV to the attribute table of my feature class. So here in this notebook, you will be able to make use of various open source libraries. Here I have made use of Seaborn, Matplotlib, and Pandas. So here using this Pandas, I am visualizing this attribute table as a data frame, and then I am manipulating or modifying the data frame, and then I am extracting different event types associated with my feature class. So for each event type, I created a feature class, and then using this hotspot analysis, I am automating the hotspot calculation for various event types. So if I am running this code, I'll be able to get various hotspot output. So here you can see in this in the background, the outputs are getting added. Yeah, I'm just unchecking this, and yeah, these are my output generated from this code. So now you saw that like when I clicked the run button, the whatever the output that I'm getting is dynamically getting added to the map. So it is a very interactive activity that is being happening here. So all the analysis that you're performing here, the output will be added simultaneously in your map window. Yeah. So this is one use case where you can you make use of the ArcPy library to handle feature class. So now I'll be taking you to another use case where how we'll be handling API links. So sometimes some useful information you will be finding in web will be in the form of API. So most of the case it will be kind of API is having, if it is a GIS related data, it will be having some GIS component within that API information, right? So here I had one API which is having the digital transaction data that has happened here in India from 2018 to 2023. So it had various data within that JSON. So every data was a JSON layer which is having a different attributes information associated with it. But I wanted only the spatial component and some of my interested information from that API. I couldn't add that JSON directly because it was having so many other components and it has to be filtered out and all. So what I could do is that I could add the API here, and I wrote a code for pre-processing the data from API, so that finally the data from JSON file was added to a date frame. Then I modified or I manipulated the data for fetching transaction data for different years, state-based data. I have created folders for storing the data. So basically from this API, I could get the information I wanted by writing script. And finally, I was able to convert the district-based transaction details to a feature class, which I have converted to a space-time cube for better visualization and better analysis. So it was a time-aware data. So it was a quarter-based data, which had the digital transaction details of India for every quarter, like a 3 months gap. For every state and for every district in India. So finally, by like analyzing and converting the data, I have created a space type queue from data, and the output will be looking like this, where each cube will be showing the transaction data for 1 quarter. Yeah, I'll be. So here you can see that you'll be seeing the date associated with it, and this is the total number of transaction associated with that. This is one workflow where I have shown if the data is coming in the form of API also, if you want to extract the spatial component or spatial data or necessary information associated with it, this automation or Python workflow can be developed to create outputs and do analysis out of it. So this is the transaction space-time cube output I have generated from that API. Okay. So till now I have told about this ArcPy and all. Now I'll be showing how you can use ArcGIS API for Python as well for automating your workflows. Okay. So for that, I'm opening my ArcGIS Enterprise. So this is the ArcGIS Enterprise front page. Yeah. So within the front page, you will be able to see an option called notebook. Okay. So in that notebook, whatever the notebook that you are writing within your Web GIS will be appearing here, and the notebooks that has been shared with you will be coming here. And if you want to like start coding, or if you want a kickstart, there are some sample notebooks available. So this is one notebook for administration for deploying automatic notification, which will be sending out notification from Python notebook if a particular user is adding or deleting a content from your ArcGIS enterprise. So various workflows can be configured there to deploy automatic notification. If you can create a new notebook by clicking in this option. So this is how the notebook interface will look like. So there are some additional like buttons here from the Jupyter notebook that you have seen in ArcGIS Pro, right? So this is the files tab where you can upload your content from your local system. So if you want to work with some local data within your ArcGIS notebook using this files option in this home, you can choose file from your local system, and it will be added here, which can be used directly from this uploaded home folder to your notebook. And in a similar manner, if you want to make use of your published content, in your notebook, you can see that if you click on this add option, you will be seeing like my content, my groups and all. So if I have to add one of this feature layer, I can just click on this add option. So the corresponding item will be added here. Okay. And apart from that, it also has some predefined code snippets. So while clicking on this analysis tab, you will be able to see different options, standard analysis tools, geoanalytics tools, and in this raster tools, you will be able to get different raster analysis workflows. So in a similar manner that we have added feature layer from ArcGIS Enterprise, if you want to add the code for calculate density, you can just simply click on this plus option so that the corresponding code will be added here. So like that, if you are new to Python, if you are new to Notebook, all the the things here will help you in uh, start coding or learn coding. So if you are not aware of any basics of code also, using this predefined code snippets, you can ingest your data and you can perform the workflows that you wanted to. So this is one basic overview of notebook server within ArcGIS Enterprise. In ArcGIS Online also, there is a similar interface we have. And now I'll be showing one of some enhanced or some interesting capability of this notebook within ArcGIS Enterprise, which is scheduling of ArcGIS notebooks. Okay. So here I have an API which is giving me a real-time temperature forecast for various parts of the world. So here my area of interest was Hyderabad. So I have written a code for fetching data, real-time weather forecast from the API, and I am getting a spatial data frame as an output. From the analysis tab, you'll be finding a code for converting your spatial data frame to feature layer. So here you'll be able to see one code, right? STF daily to feature layer. So if you have a spatial data frame, like the spatial data frame in the sense, if your data frame or CSV is having latitude and longitude information associated with it, it can be added as a spatial data frame to your ArcGIS notebook, and you'll be able to publish a feature service directly from the spatial data frame. So here the output of my weather forecast API I have added as a spatial data frame, which will be getting updated on a timely basis, and I am adding the I am converting that spatial data frame to a feature layer. So after writing this code, if you have a similar workflow like this for updating real-time data to a feature layer, but it is from an API, so you have to perform various pre-processing steps in between. What you can do is that you can write code for that, and you can take your code to ArcGIS notebook, and you will be able to have an option called task there. So under this task, you can create task, and you can enter the title for your task. If you have any parameters that you are changing within the task, you can add that. And in this task schedule details, you can schedule the task like when it has to start and what is the repeat type and repeat type interval. You can schedule everything, and you can create a task, and based on your scheduled time interval, that task will be run. So a task in the sense, this notebook will be run as a task in the scheduled interval. And if you're seeing, this is my application associated with the real-time feature service I'm updating to, and it is showing the real-time weather information of Hyderabad. And here, if I am clicking on one particular, let me reload it. Yeah, so if I am clicking on one particular sub district, it will be showing the forecast of that district. So this is for Shaikpet. It is showing me the real-time weather information for the day 29, 30, 31, and it's for 17. Yeah. And you can create real-time graphs as well with your updated feature surveys. So this is how you'll be scheduling a task within ArcGIS a notebook server. Okay, so now I'll be telling you one workflow where you can automate the report generation with one of our mobile application. So you may be aware about Survey 123 mobile application within ArcGIS Enterprise, right? So Survey 123 is a mobile application which can be used to fill spatially aware surveys from mobile or web like that. So in Survey 123, various kinds of survey workflows can be configured. So you will be able to create surveys with the attribute field you have to collect information. And after you create your survey using this mobile or web interface, the user can update the information, right? So I am just showing you one workflow where I had one survey form for collecting the railway track details. So railway track details in the sense the railway track has to be surveyed in a periodical manner, right? So we have to check for any deformation or any other kind of thing, right? So after the survey, if the administrator want to see the report on a timely basis, you can use Python or ArcGIS API for Python for automating the process. So I'm just showing you one uh, workflow for that. So here within ArcGIS Pro itself, you will be able to establish a connection within your enterprise or AGL. So if you are connected to AGL from here, if you are adding GIS of home, it will be automatically connected to your enterprise. Or if you are connected to AGL here, it will be connected to AGL. So based on the connection established here, the GIS of home method will be establishing a connection. So here I am establishing a connection within my enterprise, and here I am getting my survey form ID. So this is my survey. I'll be just showing how the survey will look like in my. Yeah, while it load, I'll show you the workflow. Using this command, I am fetching my survey application that I have configured in my enterprise, and my survey name is Railway Track Survey. And I am generating a default report template for the survey. So as soon as the field user fill the information using this default report template, I'll be able to download the report. Right? I wanted to like create my own report template for that. So for that, I have added a sample report, a customized sample report to my ArcGIS Enterprise, and based on that sample report layout, here I am generating a report. Based on that sample report template, I am uploading to. If I am scheduling this notebook, whenever the field user is updating the information through his mobile or web, I'll be able to get the report. So here you can see that I have converted this entire code to a geoprocessing tool. So in this geoprocessing tool, if I open it, I also have an option for scheduling it. So this entire notebook will be scheduled and will be run on a timely basis based on the interval that I am defining here. So here, if I am going to my content page, here you can see that I am getting my output as a folder which is called all params. So here I'm getting my output as a folder named all params package. So I can go here and this is my output and I can download it from there. So I'll be able to get a zipped folder. So if I extract my zip folder, it will be looking like this. For every records the field user is updating, I'll be getting a corresponding document or PDF report. You can specify the report type associated with it. So here you can say that it's a survey name and date of survey and the photo captured by the reporter, and this is the corresponding geolocation associated with it. So likewise, you can define your own template and you will be able to get, the administrator will be able to get the report on a periodic basis. Yeah. So that was about some of the Python capabilities or workflows within ArcGIS.